Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on Precalculus. This is question number 15. This question is pretty tricky because you have to remember a result about the sum and product of roots of a polynomial. So I'll just remind you what that is. If you have a polynomial, for example, p of x equals a to the nth power, a sub n times x to the nth power, in other words, an is the coefficient of x to the n, plus an minus 1 x to the n minus 1 plus ... plus a naught. Then the sum of the roots is going to equal negative, I'll just write it like this, the sum of the xi's, where the xi's are the roots, is going to equal negative a n minus 1, in other words, negative the coefficient of x to the n minus 1, all over an, the coefficient of x to the n. And the product of these roots, I'll write it this way, product of the roots xi is going to equal negative 1 to the n, in other words, if we have a polynomial with even degree, that's just going to be 1, times a naught over an. Okay, now this looks hard to remember, but in the quadratic case, it's not so bad. I'll show you what I mean. If we have a quadratic equation, like ax squared plus bx plus c equals 0, okay, so this is a polynomial of degree 2, then remember the quadratic formula tells us that the two roots, x1 and x2, are going to equal negative b plus or minus the square root, one of them will be plus and the other root will be minus, the square root of b squared minus 4ac all over 2a. Now if we take the sum of these roots, like x1 plus x2, then this part is going to cancel out, and we're left with just negative b over 2a plus negative b over 2a, which is negative b over a. And that's the same as negative a sub n minus 1 over a sub n, because b is the coefficient of x, which is our x to the n minus 1. Now the product of x1 and x2 is going to be, well, this has the form of u minus v times u plus v. I'll just remind you that u minus v times u plus v is equal to u squared minus v squared, where in our case u is going to be negative b over 2a, and v is going to be this whole thing, square root of b squared minus 4ac over 2a. So x1 times x2 is going to be the square of u, which is going to be b squared over 4a squared, minus the square of v, which is going to be b squared minus 4ac all over 4a squared. Now we already have a common denominator, so if we simplify this, we get, well, the b squareds are going to cancel out, and we end up with negative 4ac, so that's going to be positive 4ac over 4a squared. Well, the 4's cancel out, one of the a's cancels out, so this just gives us c over a, which works out because c is our a naught in this case, and a is our an. And then it's even, so the negative 1 squared is just going to be 1. Alright, how is this going to help us with this problem? Well, if we look at this equation, at this problem, then we can tell that here, if we write, suppose that x squared plus little bx plus 1 equals 0. That's one of our equations. And suppose that the roots are s and t. Then what do we know about the sum of s and t? Well, we know that s plus t is going to be equal to negative little b. Okay, because a is 1 in this case. And we know that the product of s and t is going to equal just 1, because a is 1, c over a, so 1 over 1. Well, we are told that the roots of this, of x squared plus big bx, x squared plus big bx plus 1, we're told that the roots of this equation are the squares of the roots of the little equation. In other words, s squared, let's go over here. In other words, here our roots, x1 and x2, are going to be s squared and t squared. Well, that means that s squared plus t squared has to equal negative big B. Well, what's s squared plus t squared? That's just s plus t, quantity squared, which we know what that is. That's going to be little negative b, minus 2st. Well, we know what little st is. That's going to be 1. So this whole thing is going to be negative b squared minus 2 equals negative big B, which means that our big B is equal to 2, this is going to be negative b quantity squared. So this is going to be 2 minus little b squared, which is a.